Welcome to Python Basics with EJD. In this video, I'll be talking about advanced Python functions. We started with Python functions in the previous video, and that took so much time. Interestingly, we still have some more advanced things. And since we use Google Colab, I'll just come here, click on Google Colab, and then look for advanced Python functions. Okay. Now it comes on, yes, advanced Python functions. So we already know that functions are blocks of codes that enhance readability, and they also help with modularity. Like you can have smaller chunks of codes and then build something large out of all that. Okay. So talking about advanced Python functions, right? The first advanced function we want to see are nested functions. A nested function is a function can be defined inside another function. That's the idea of nested function. So you have a function and then you define another one inside of it. That's different. Maybe that's slightly different from the idea of function of a function, like we said the other time, like higher functions. So you can have inner function can only be accessed inside the outer function, and it is useful for, excuse me, encapsulation and modular logic. For instance, you define a function which is the outer function, and it takes a text and then you define an inner function. Then the inner function, so the inner function prints inner, so whatever the inner says, it takes whatever text you supply here. So the inner function says what the outer function takes in as text. And then you end up with the inner function being called here, so that by the time you say outer function is hello from outer, and you just have that hello from outer. Of course, when you run the first time in a session, it takes a bit of time. Then the other ones are faster. Okay. So what if I say something like this now? Just say hello. So the text I put in now is hello from the other side. Hello from the other side, you know. So that now we have, so inner says hello from the other side. So the outer makes inner say what it has to say. So the outer function supplies the inner function what to say. That's the idea here. So that's a nested function, a function defined inside another one. So we have what we call closures. Okay. So a closure is a nested function that remembers the state of its enclosing scope even after the outer function has finished execution. I mean, this is a bit more complicated. That's why we're talking about advanced functions, right? So imagine you define an outer message. If you define a function called outer and it takes the parameter MSG, whatever message you have to send, and then you now define an inner message, and then you print message. So whatever the message you supply for the outer, so the inner one prints it, and then the inner one returns the inner message, so returning the inner function. Then once all of that is done, you now have, if you say my func outer hello closure, so it prints. Okay, I think we need to separate these two to make so that we can understand clearly what's happening. So I do alternate enter. Okay, it doesn't say anything. Okay, I can put it back. So my func, so outer hello closure, but it doesn't, so it just takes the outer thing. So finally, we now say my func, and then it now runs hello closure. So it's a bit complicated. So it's a closure is a nested function that remembers the state of its enclosing scope even after the outer function has finished execution. So when you did outer, it didn't run until you now run so this my func now. So maybe what would have happened is to say print my func also, then it would have happened like that. Okay, so I think I don't need this one anymore. So I can just escape and do DD for that. Does that work? Escape DD. It doesn't work like for Jupyter Notebook regular. Okay, so this can go. Now, so what this does is that it is used to maintain private state. Okay, so if you want to keep something secret, you can use closures like that. Then another thing is we can do the same thing here. Imagine you define counter. Okay, So you define a counter, the function called counter, and then you initialize count from 0. Then you define increment. So counter and then the increment, and then you have a non-local count which modify the outer variable, right? So, and you say count plus equals 1. What this means is that so of course the initial count is 0. So count plus equals 1, like we learned under arithmetic operations, is that count will increase by 1 and takes the new value, right? And then returns the count, and then it returns the increment. So each time, so you now say the C now is now counter. So once you do the C, which is counter, then you can now you can now continue to count with that. So say print C, you know, print C, that's one, print another C2, and keep going like that, until there's no end. Like you can just keep going like that. So that's closure. It's a bit complicated, so you need to really sit down to get the gist, right? So that is a closure that, as we saw, it's a nested function that remember the state of its enclosing scope, even after the outer function has finished execution. So the outer execution already finished there when we said counter, you know, but then the inner one can now continue incrementing based on what the inner one takes. Then we have what we call decorators. So a decorator is a function that modifies another function. So a function that modifies another function is called a decorator, and it is used for logging, authentication, timing, and memoization. Not memorization, it's memo. So like writing memos, memoization. So see what happens here. You have this. You define a decorator that takes parameter func, and then you define a wrapper with multiple arguments and multiple keyword arguments, like we saw in the under the function video. Then and what it does is it prints function call, and then the result is whatever func you have here, the arguments and the keyword arguments, and they can now print after function call. So return result and then return the wrapper, and then you now have a decorator. So the decorator is apply decorator using art. So whatever you have now, this is going to help you wrap it. That's the whole idea. So you say define, say hello, then you supply a name, okay, and then print hello, print f hello name. So if you say hello Ali, see what's going to happen. So you see, it says before function call, that was printed. After function, so before function call, you have this, then hello Alice, then after function call. So it means that what this wrapper has done for whatever you have here now is the wrapper decorates the function before and after, this whole decorator part. And then the main thing you are implementing, maybe I can even give a space. So this is another function right here, okay, that is being implemented here. But then the decorator helps us to do before function call and after function call around that function, around that other function that was called. So it means that the nested function here is decorating this standalone function in line 11 and 12, right? So let's talk about decorator with arguments. So we can have decorators with arguments. So imagine define repeat times, define decorator, define wrapper. This is a three nested function. So define repeat, it to take parameter time, define decorator, it to take parameter function, define wrapper, it to take arguments and keyword arguments. Then for anything in range of the times you have here, then you have the function arguments and keyword arguments. Then you can return the wrapper and return the decorator. And then, so the decorator now, to apply it, you have at repeat 3, right? At repeat 3 right here. So if you now say define greet name, print, so this decorator now is decorating this function, but then it's taking arguments. So you have print hi name. So if you now say greet Bob, see what happens. Greet Bob. So it means that it is going to, any greeting you make, it's going to repeat it 3 times. So imagine that you need to do an imposition. Like I think I gave that example in a previous video. They now say greet. So it now say greet. I will never come late again. I will never, oh, let me say, I will always come early. I will always come early, early. I will always come early. I will always come early, sir. So it gives that to us three times. So the decorator function here, which is a nested function, is repeating whatever you do for the function it is decorating, like that. Then we have what is called function catching and memoization. So catching is storing the results of expensive function uh, calls to avoid recalculation. So because of recalculation problems, we can, we can store the results of expensive function like that so that it's I think the idea of catching in computing normally is that you store imagine the first time each time I open Google Colab, so the first running I do on any code, it takes a bit more time, but after that is done, every other one is faster, of the same, at least of this of equivalent complexity, let's say, so for manual memorization, and you want Fibonacci, so you and then you define the catch here right away. So that's for memorization. So you define a catch. So if n in catch, so whatever n in catch, so return catch n. So if n is less than or equal to 1, so catch n is n, else. So whatever value we have here, we don't have to compute it all over again each time because of the catch thing. So that if you now need to do very big things like fib 10, and so you have 55 like that. So you jump to that end. Imagine if we need like fib 100. So it gives us that very large number straight up. So it just jumps there. So because of memorization, so it doesn't have to do the computation all over again each time. So we can also use functools.lru catch. Okay, so we are still talking about catching and memorization. So from functools, we import lru catch. So here now, you now have something like a decorator. So you have lru catch, maximum size none, unlimited. So that is unlimited catch because there's no maximum size. So you now define fib underscore lru, take a value n. So if n is less than 2, return n. Then return fib lru n minus 1 plus f LRN minus 2. That's the whole idea of Fibonacci. So if you now do LRU 50, so this is very fast, even for a large number, right? So it will be very fast. So even if you go 100, so what the whole thing is doing, it's that it's making things pretty fast, right? It's under 1 second actually. So we can still have advanced higher order functions. The other time we talked about higher order functions where a function can run taking another function. So here now we define multiply by n. So maybe we are multiplying by n, then a nested one multiply by, then we have multiplier x now. So return x times n. So supply n, supply x. So you multiply the x and then return the multiplier. And then you now have double multiply by 2, triple multiply by 3. So if you now say print double 5. So in this case now, double 5 is just that whatever you have. So double is actually multiplying by 2. So 2 times 5, triple multiplying by 3. And we have 10 and 15 like that. Now we can still have partial functions. So from functools, this allows freezing some arguments of a function and then simplifies repeated calls with fixed parameters. So from functools, we can import partial. So we define power base exponent. So return base raised power exponent. So if I say square partial, I say power exponent 2, cube partial power exponent 3. So those will give us the square of 5 and the cube of 2, like that. Okay. I mean, all these advanced functions, they can be quite complicated, and the most of what they may do, you probably may already be able to do with the regular functions, right? Then we can do anonymous functions too, like we can have advanced lambda in this situation. So lambdas can be combined with map, filter, reduce, and sorting keys, like what we did in the previous video. So for functools, we need to import reduce. So you have number 1, 2, 3, 4, 5. So sort by remainder when divided by 3. Okay. So when you divide any number by 3, sort by the remainder. So 1 by 3 is 0 and the remainder is 1, So in this case now, it's sorted number. So key lambda x such that x modulo 3. So it means you're going to have 1, 2, 0, 1, 2, something like that. That's the result you're expecting here. So that's the sorted numbers after dividing by 3. So when print sorted numbers, so I don't think, would this be correct? I doubt it. I suspect that the answer is going to be 0, 2, I mean 1, 2, 0, 1, 2, 1, 2, 0, 1, 2. That's what I think for the sorted number. So it won't just be this sorting directly like this. So I doubt if this is going to be 8. Now we talk about the sum of squares now. So sum of squares, lambda ACC. So you have x ACC plus x squared. So um so sum of squares. So you square each one and then sum of them all together. Then number 0. So all of that is going to give us 55. Oh, okay. Sort by remainder when divided by 3. Sort by remainder when divided by 3. I think maybe this is okay. Remainder when divided. Okay, I get it now. So normally, right, there are 2 layers to this, right? Um, normally, if you divide, if you divide by 3, so 1 divided by 3 is 0. I mean, it's 0 remainder 1, okay? Then 2 divided by 3 is 0 remainder 2. Then 3 divided by 3 is 1 remainder 0. We just take the remainder. 4 divided by 3 is 1 remainder 1. 5 divided by 3 is 1 remainder 2. So if you now want to sort now, based on that, so we have something like this. So if you want to sort based on that now, so 0 is the least, right? So you now have 3, this 3 that gave you 0, sorry, 3 that gave you 0 is in the middle, okay? So you have 3, then the next one, the ones that gave you 1, so that will be 1 and 3. So that will be 1 and 4, rather, 1 and 4. And then you have 2 that give you 2, and finally 5 that also gave you 2. 5. So it's a bit tricky, really, right? So, and for squaring here, we have 1 squared, that's 1 plus 4, 5. 5 plus 9, 14. 14 plus 16 is 30. 30 plus 25, that's why we have 55. So for this one, for sum of squares right there. So this is really tricky. You need to really settle down to get the gist. So introspection of functions. So functions in Python can be examined dynamically. So imagine define greet name, string goes to string. So greet a person and return hello of the whatever name, right? Then, so you can now say print greet name, print greet doc. So this one will actually greet, then this actually greets a person, and then this one gives the annotation, class, string, and all that. So these advanced ones are pretty much, they require some time to really comprehend, right? So this is giving us some kind of introspection. This is telling us what exactly these things are doing, right? So this one just says greet. Then when you talk the documentation, it greets a person. And then lastly, this one says it takes name, which is string, and returns another string, basically. All right, so we come to the end of this. Key takeaways, you may need to look at it a couple of times to really get the gist, right? So key takeaways for advanced. Nested functions encapsulate logic inside another function. Then closures allow functions to maintain private states. So when we get to object-oriented programming, we are going to say things like, is it, okay, when we get there, we remember it's something about anonymization or something like that. You see that when we get to object-oriented programming, when we begin to create classes, then we have decorators which enhance or modify functions elegantly. Memorization or caching boosts performance of recursive or expensive computation. So if you are doing expensive computation, so you save it ahead so that by the time you need it again, you don't have to go to start from the scratch. Then higher order functions and partial functions provide reusable abstractions. Lambda functions remain useful for concise operations in combination with functional programming tools. Python functions are first-class objects. They can be passed, returned, and introspected. So functions they can be very useful and tricky, right? So you want to really sit down to get what the gist is about. All right, so with this, I come to the end of this video. Let me know how helpful this is for you. And if there's something you'd like me to try out, feel free to let me know. If you have not subscribed already, you know you're missing a lot. If you have subscribed, thank you so much. So if you have not subscribed, please go ahead and subscribe. Hit the notification bell also so that you can always get alerted each time a new video is released. And having done that, you can take it a step further. You can become a member of this channel. You click on join. When you get to my channel, you see join, just click on it. You see three levels of membership, and each one comes with a level of benefits you stand to gain as a member of the channel. Ultimately, don't forget to like, share, comment so that more people can have access to the great content that I have going on here. Till I come your way again, keep doing Python well. Bye.